Okay. What we have studied last lecture?
Architecture and its three styles.
Okay. Architecture and its three styles of modeling, or you can say three types of modeling, right? First one is a behavioral data flow. Second one and third one is,
Structural.
yes, exactly. Third one is structural modeling. And I hope all of you have clear with the what do you mean by data flow, or in which manner we supposed to design in using a behavioral style. Similarly, in which manner we have to design using data flow style and using structural style. Okay, again I will revise it in brief. Data flow, process statement has to be there, right? And we have to design in such a way that it will narrate the overall behavior of your design, right? It will tell the behavior of your design, and by using process statement. And again, process statement is concurrent. What are the statements comes under process? That are the sequential ones. Okay, you have to remember this point. Then comes to the data flow style of modeling. In data flow style, you can use process, or you can omit process statement. You have to use a boolean expressions in data flow style of modeling. For example, if you want to design full adder, the equation for the sum and equation for the carry, you have to mention there, right? That style of modeling is called data flow style. And in structural style, you have to split your design into two subparts, and you have to write a code for that subparts that forms the entire code. For example, you can directly design full adder with the help of boolean equation, no problem, that is okay. But even you can design full adder by using two half adders and one OR gate, that is also possible. So you have to, that means you have to split your design into two small parts, or two, not compulsory two only, you can split into n number of parts, and togetherly you have to code for that small parts, and that together design forms the your entire design. That means two half adder followed by OR gate, that will behave as a full adder, right? So that is all about the structural style of modeling. And again, I have told you one more point also. In structural style, process statement should not be there. स्ट्रक्चरल स्टाईल मध्ये प्रोसेस स्टेटमेंटचा वापर होत नाही. समजलं इथपर्यंत सगळ्यांना? अप टू दॅट पॉइंट वी हॅव डिस्कस्ड इन लास्ट लेक्चर. Now, already we have discussed the different sections of VHDL code, such as libraries, then entities, then architecture. We have already discussed the entity part, we have discussed the architecture part. Now it's time to discuss the library. Now in this library, there may be some packages, and in that packages there are maybe some configurations. So packages and configurations, you can say, that are the sub parts of the library only, that are the sub parts of library only. But here, for your understanding, we are taking it as a different parts. Okay, there are only main three parts only: library, entity, and architecture. But again, in library, we are taking it sub parts also: packages and configurations. Now we will discuss what do you mean by packages, what do you mean by configuration, and again we will discuss something about libraries also, that we are going to use in our VHDL program. Now we will start with the packages. Now what do you mean by packages? Have you heard this word before, packages type? Now packages are the collection of the some constant, some sub programs, or some data types, right, that collected together and stored into one what we can say package. And that package you can use in your further programs, in your further designs, or the one package can be globally shared with many design units, many design units, a single package. And what contains in that package? There may be some sort of sub programs you have written, right? There may be some sort of constants that globally you have declared. There may be some additional data types you might have used. So all that contains in a one package, and that package can be used or that can be shared globally, and that can be used simultaneously by more than one design units. That means that more than one design unit can enable or can use a same package. And what is inside that package? Packages मध्ये काय असतं? There may be some global constants, there may be some sub programs, a small sub programs that you need to use frequently, right? So there may be some sub programs, there may be some data types, a specially defined data types you can store there, or some constants, global constants you can mention there. So that total forms the package, and that package you can what we can say, provide to the many design units, and many design units can access that package simultaneously. All of you clear with what do you mean by package? Package म्हणजे काय, की ग्लोबली ज्या टर्म सारख्या सारख्या यूज होतात त्या एका ठिकाणी आपण स्टोअर करतो. And once you know that define that package, then you need not to mention that constants and sub programs again separately. आलंय लक्षात? त्या पॅकेज मध्ये जे सब प्रोग्राम किंवा कॉन्स्टंट किंवा डेटा टाइप्स तुम्ही जे त्या पॅकेज मध्ये इन्क्लूड केलेले आहेत ते तुम्हाला परत सेपरेट लिहायची गरज नाही. Once you declare that package, your job is over. That sub programs and all that are being considered automatically. समजलंय का?
Yes, sir.
Okay. Now, the package can consist of two separate design units. First part is a package declaration, and second part is a package body. Now, means that package has two labels: package declaration and package body. That means it has two separate design units: package declaration, package body. Now, what do you mean by package declaration? Now, the package declaration contains all the names of the item, and that will be seen by the design units that uses that package. All the name in package declaration, you there are what are the contents, म्हणजे थोडक्यात त्या पॅकेज मध्ये काय काय आहे ह्याची नावं त्या पॅकेज डिक्लेरेशन मध्ये असतात. म्हणजे त्या पॅकेज मध्ये what are the parts or what are the items that are included in that package, that we have to declare using package declaration part. म्हणजे थोडक्यात त्यांची नावं असतात, या पॅकेज मध्ये काय काय आहे, हे आहे, हे आहे, हे आहे. So that is all about the package declaration. Now in package body मध्ये काय असतं? The package body contains the sub program parts. लक्षात घ्या, पॅकेज डिक्लेरेशन इज डिफरंट, पॅकेज बॉडी इज डिफरंट. पॅकेज डिक्लेरेशन मध्ये काय असतं? जस्ट नेम ऑफ द आयटम्स, अँड दॅट द डिझाईन युनिट कॅन यूज. पॅकेज डिक्लेरेशन मध्ये नेम ऑफ द आयटम्स असतं की त्या पॅकेज मध्ये काय काय आहे. आणि पॅकेज बॉडी मध्ये काय असतं? तर सब प्रोग्राम्स आर इन्क्लुडेड इन पॅकेज बॉडी, अँड this package declaration and package body togetherly forms the entire package. Package declaration and package body togetherly forms the entire package, right? म्हणजे पॅकेज मध्ये काय काय असतं? पॅकेज डिक्लेरेशन, पॅकेज बॉडी. पॅकेज डिक्लेरेशन मध्ये काय काय असतं? नेम्स ऑफ द आयटम्स दॅट डिझाईन युनिट कॅन यूज. त्या पॅकेज मध्ये काय काय आयटम्स आहेत हे पॅकेज डिक्लेरेशन मध्ये असतं. आणि पॅकेज बॉडी मध्ये काय असतं? इन पॅकेज बॉडी द सब प्रोग्राम्स आर included in that body, or in package body there is implementation design of sub programs are declared, and this package declaration and package body togetherly form the entire package. समजलंय? Now again, as we have discussed, there is typical syntax for the entity declaration, port declaration, generic declaration. There is syntax for architecture declaration. Now similarly, there is also a typical syntax for package declaration also, or package for package there is a particular syntax. Now what is that? You can see on your screen now. So this is a typical syntax for package declaration. So package, then package name, then in curly bracket package declarative items, means in that package what are the items that you have included. You have to list out that items in this package declarative part, and then finally end package name, right? So this is package declaration. Now second part is package body. So what is syntax for package body? See, this part is package declaration syntax, and this part is package body syntax, and this entirely form the package. This entirely form the package. Package declaration plus package body entirely form the package. And this is the syntax for package declaration. This is the syntax for package body. Clear with this? Now we will discuss the syntax for package body. What is syntax for package body? Package name, then again package declarative item. That means in this case now the package declarative item may be a subprogram. Package body मध्ये the package declarative item part can be replaced by some subprograms. This part can be replaced by some subprograms, right? And finally end package name. Whatever the package you have started with the same name, you have to end with the same name. So that is all about the packages. Package syntax. Packages has two parts of design unit: package declaration, package body, that entirely forms the package. Now in package declaration, the names of all items present in that package has to be mentioned. That means the package declarative items, what are the items contained in the package, that comes under the package declaration. And in the package body, the sub programs may be there, right? So this package declarative part can be replaced by sub programs. You can write some sub programs there. You can write some sub programs there in package body part. Clear with this? Okay. Now here you can see the example of package declaration, how to actually use this syntax of package that I have discussed with one example. So you can simply go through it, and if you have any doubt you can ask me. ते एक्झाम्पल आहे जे स्लाइड वरचं ते बघा. त्याच्यात पॅकेज डिक्लेरेटिव्ह पार्ट, पॅकेज बॉडी, and again this part is about code. This part is actually the sub program, right, in the package. This part you are able to see is the sub program, because in the package body we can include the sub program. So you can see here, if else statement I have used, and I have written a simple sub program here. So this is the example of the actual use of package. Example बघा, काही डाऊट असेल तर विचारा. All of you are through with the example? In this you can see this package is a package declarative part, right? We have declared package here. We have mentioned the subtypes. We have globally initialized some constant with its initial values. Then we have come to the package body part. In package body part, we have written a simple short sub program here, and end of the package name. Now you can see all package names are same. X_pkg. This is the package name, and we have used the same name at all places. So first part is a package declaration part, and second part is a package body part. In package body, you can see there is one sub program is there. So this is all about the package declaration and package body, and entirely forms the package. Are you through with the purpose of using packages? Why to use package? Because in packages there are many sub programs you can declare. There may be some global constant you can declare. There may be some data types that some special data types you can mention there. And once you declare that package, or once you include that package in your program, then again there is no need to separately declare that constants and separately write that subprogram, right? म्हणजे एकदा ज्या त्या पॅकेज मध्ये जे जे काही आहे ते एकदा ते पॅकेज तुम्ही इन्क्लूड केलं की ते पार्ट तुम्हाला परत प्रोग्राम मध्ये लिहायची गरज नाही. सिम्पली तुम्ही पॅकेज लिहिलं, दॅट्स ऑल. नाउ यू कॅन यूज एनिथिंग व्हॉट एव्हर द कंटेन्स इन दॅट पॅकेज. यू कॅन यूज एनिथिंग व्हॉट एव्हर कंटेन्स इन दॅट पॅकेज. एकदा पॅकेज लिहिलं की त्या पॅकेज मधले आतलं काय ते सगळं तुम्हाला मिळतं, ते परत तुम्हाला लिहायची गरज नाही. सो दिस इज ऑल अबाउट द पॅकेजेस. I hope you have clear with this package example. Now we will discuss the next part of the or we can say next part of the program, that is configurations. Again I will repeat. First part is library. In library you can include many packages, and in packages you can include many configurations. So in all, package and configuration can be treated as a subtype of library. Again I'm repeating that. In all, packages and configurations can be treated as a subtypes of libraries. Okay, library is a main thing. Understood? Okay. Now what do you mean by configurations? Configurations म्हणजे काय? Now in your architecture, that means in your design, you can know a same entity can be used by, or same entity can have several architectures. More than one architecture you can use with the same entity. Entity is common, but the same entity you can use for many architecture part. Now for a design purpose or for a designer, if you want some typical part of the code and that you want to use for the research purpose or for the experiment purpose, so what will be the solution to that? Now the configurations are solution to that. That means during the design process, a designer may want to experiment with different variation of a design by selecting different architecture. Now the configurations can use to provide fast substitute of components instances in that design or a structural design. म्हणजे काय तर एक एंटिटी असते ती खूप आर्किटेक्चर यूज करू शकतात. द वन एंटिटी कॅन बी युज्ड बाय मेनी आर्किटेक्चर, बट नाउ फॉर पर्टिक्युलर डिझाइन, if designer want to experiment with variation of the selecting different architecture, बरोबर आहे, तुम्हाला डिफरंट आर्किटेक्चर वर एक्सपेरिमेंट करायचे, अँड दॅट टू यू कॅन यूज दॅट पर्टिक्युलर आर्किटेक्चर मेनी टाइम्स इन युअर फ्युचर डिझाईन्स ऑल्सो. So you can store that particular architecture as a component. म्हणजे तो पार्ट कॉन्फिगरेशन, तो पार्ट तुम्ही कॉन्फिगरेशन म्हणून स्टोर करू शकता. And in future, if you simply mention that configuration, the entire architecture and entire that design you can use many times in your future designs also. म्हणजे लक्षात येते की तुम्हाला एक you have designed some 2-3 architecture by using one entity, and in future also you require that particular architectures for your future research purpose. Now what you can do, you can store that architecture as the configurations, and in future you can use a simply configuration. नाहीतर मग कसं करावं लागेल, परत तुम्हाला ते आर्किटेक्चर तयार करत बसावे लागतील. Now you need not to again design that architecture if you store that architecture as a configuration. म्हणजे एकदा तुम्ही ती जे काही 2-4 आर्किटेक्चर तुम्ही तयार केलेली आहेत ती तुम्हाला परत वापरायची, मग तुम्ही ते परत लिहित बसणार का कोड प्रत्येक वेळी त्या आर्किटेक्चरचे? नाही. मग काय करायचं, तुम्ही ते आर्किटेक्चर कॉन्फिगरेशन म्हणून स्टोअर करायचे. त्या आर्किटेक्चरचं कॉन्फिगरेशन तुम्ही स्टोअर करायचे, आणि मग जेव्हा केव्हा परत तुम्हाला ते आर्किटेक्चर्स यूज करायचे, यू सिम्पली मेन्शन द कॉन्फिगरेशन नेम अँड दॅट आर्किटेक्चर विल कम इन टू पिक्चर. समजतंय की तुम्हाला डिझाईन साठी, इफ यू वॉन्ट टू experiment with your design, right, you want to use some 2-3 or different architecture, right, and again that architecture if you want to use in some different design, so प्रत्येक वेळी मग तुम्ही ती नवीन प्रत्येक वेळी ते आर्किटेक्चर लिहित बसणार का? प्रत्येक वेळी लिहित बसणार का? सपोज तुम्हाला इथनं पुढे 10 डिझाईनला ती लागणार आहेत, मग 10च्या 10 डिझाईन मध्ये तुम्ही ते नव्यानं लिहित बसणार का? तसं नाही करायचं. मग ह्याच्यावरचं सोल्युशन काय की you can actually store that architecture into a configuration, and in your further design part or in your future design, if you mention that simply configuration name, the architecture will get enables to you. म्हणजे ते आर्किटेक्चर तुम्हाला परत लिहायची गरज नाही. एकदा तुम्ही ते कॉन्फिगरेशन म्हणून स्टोअर केलं की ते परत लिहायची तुम्हाला गरज नाही. इफ यू सिम्पली मेन्शन दॅट कॉन्फिगरेशन पार्ट, your job is over. That architecture automatically will come into picture. समजलंय? Okay. Now again, this configuration has its own syntax, right? Configuration, then again configuration name, the entity name, बरोबर आहे? Because that all architecture are connected to one entity only. Entity एकच आहे, architectures खूप सारे आहेत. मग entity name you have to mention, and that to be a unique one. बरोबर आहे? एका एंटिटीचा वापर करून तुम्ही अनेक आर्किटेक्चर डिझाईन करू शकता. पण मग ती आर्किटेक्चर तुम्हाला परत दुसरीकडे वापरायची असतील तर तुम्ही काय करणार? त्या आर्किटेक्चरचं कॉन्फिगरेशन करा, अँड देन यू कॅन यूज दॅट कॉन्फिगरेशन पार्ट इन युअर नेक्स्ट डिझाईन. म्हणजे परत तुम्हाला ती आर्किटेक्चर लिहायची गरज नाही. I hope all of you are through with this. Okay. Now this is the typical syntax that can be used for configuration: configuration name, entity name, then configuration declarative part, then for block specification, right? Means whatever the configuration, how many times you want to use that architecture, or how many times you have to use that small design that you can design for with this block loop, for loop, and end for. That means we have started the loop, we have to end the loop. So this is the typical configuration part, or you can say this is the need and necessary of configurations. So again, this is what the example of configuration I have displayed here. You can go through it, no problem. So this is configuration, this is configuration name, this is entity name, right? FADD underscore config, this is configuration name, this is entity name, full adder is the entity. And what is configuration? FADD underscore config, this is configuration name, and full adder is a entity name. Is for structure, you have to use that for loop will get executed this much times, and again and for end configuration. Whatever you have started, you have to end with the same title. So that is what expected. So this is all about the configuration example, right? If you have any doubt regarding packages configuration, you can free to ask. If you have any doubt regarding this part, you can ask. Okay. Now next part that we will that we are going to discuss is design libraries. Already we have discussed this part. What is need of library, what is use of library, but again we will discuss this part in brief. Okay. Now, as you know, library is a very essential and very required part of your any design, VHDL design, because without library you cannot proceed with the entity and architecture. You have to mention the libraries that you are going to use in your design purpose. Now the library contains the following unit: packages, entities, architecture, configuration. As I told you, packages and configurations are the sub part of the libraries only. But again, VHDL does not support any hierarchical library. You can have as many as you want, but you cannot nest them. Means what? You can use many libraries, whatever you require. If you require 2, 3, 4, 5, 6 libraries, you can mention at the start, and you just simply start writing your code. But VHDL does not support any hierarchical library. That means VHDL don't have its own library, but VHDL can use many libraries. Understood the meaning of this statement? VHDL does not support hierarchical libraries, but you can use many libraries, but you cannot nest them. That means VHDL don't have its own library, but you can use a mini library into it. A simple meaning of this statement is I mentioned you. VHDL don't have its own library, but VHDL can use many libraries at a time, and also you cannot nest them. Also, you cannot nest them means you cannot interconnect there, or you cannot what you can say combine them and form a one library. No, every time depending upon your need of design and depending upon your implementation, right? So you can simply mention the libraries that you want to use, and you proceed with your design. You just proceed with your design, right? Now again, to declare the library, again library has its own syntax. What is that? This library, then library name, colon, its path, and its directory name. Means where you want to store the, what are the contents of the library, where you want to store in your what you can say memory. So path and dictionary directory name you have to mention, where you want to store onto your C drive, D drive, in C drive which folder. So that will be the directory name, right? So this is all about the library name and its syntax. Now you can access the compiled units from the VHDL library up to 3 levels of name. That means up to 3 levels of depth you can compile the VHDL library. What is syntax for that then? Library name, then library have the package name, and that package which item you want to use. Means library, inside library there is a package, and inside package there is a item. So you can use up to a 3 level. Library name, package name, and in that package which item you want to use, or which subprogram you want to use, or which constant, which data types, that all are contained into a package. Which which item of that package you want to use, you can mention here. So this is all about the design library. Okay, this is syntax for the library declaration, and this is syntax for the, if you want to use a package and in that package some item of that library, then you have to go for this syntax. And if you simply want to use that library only, you can go for this syntax. If you want to use library with package and with some particular item, you can go with this syntax. I hope you're clear with this. Now next part is data objects, right? The same thing you have studied in C language also. So again, with some different context of this behavioral programming, we have to study data objects, data types. What do you mean by signals? What do you mean by variables? Difference between signal and variable. All that we are going to discuss in this language also. Because always remember, you take any language, you take Python, you take Java, you take .NET language. Each language has its own syntax and its own significance, and that way you have to study that syntax, and then only you can able to write a code regarding that language or with use of that language. प्रत्येक लँग्वेज असते त्याचा एक स्वतःचा सिंटॅक्स असतो, त्याचा एक स्वतःचा फॉर्मॅट असतं. तसं आता आपण त्या व्हीएचडीएल लँग्वेजचं फॉर्मॅट शिकतोय, सो दॅट वी कॅन इझिली राईट अ कोड इन व्हीएचडीएल लँग्वेज. बरोबर आहे की नाही? तसं सी शिकायच्या आधी तुम्हाला सी मध्ये डेटा टाइप्स कुठले शिकावे लागतात, डेटा ऑब्जेक्ट्स कुठले शिकावे लागतात, इंटिजर म्हणजे काय, फ्लोट म्हणजे काय, हे सगळं शिकावं लागतं. बरोबर आहे का नाही? सीचा सिंटॅक्स शिकावा लागतो, हेडर फाईल्स कुठल्या यूज करायच्या हे शिकावं लागतं. तसं व्हीएडीएल मध्ये सुद्धा त्याच्या लायब्ररीज कुठल्या आहेत, आर्किटेक्चर कुठले आहेत, डेटा टाइप्स कुठले, डेटा ऑब्जेक्ट्स कुठले आहेत, पॅकेजेस म्हणजे काय, कॉन्फिगरेशन म्हणजे काय, सिग्नल्स म्हणजे काय, व्हेरिएबल्स म्हणजे काय, व्हॉट इज डिफरन्स बिटवीन सिग्नल अँड व्हेरिएबल, where to use signal, what are the concurrent statement in this VHDL language, what are the sequential statement in the VHDL language. All these things you have to learn first, and then you can able to write the VHDL code. हे सगळ्या गोष्टी म्हणजे आपण आता त्याचं कोडिंग टेक्निक शिकतोय की कसं, काय काय स्टेटमेंट्स आहेत, काय काय लूप्स आहेत, कॉन्करंट स्टेटमेंट्स कुठले आहेत, सिक्वेन्शियल स्टेटमेंट VHDL लँग्वेज मध्ये कुठले आहेत. नाउ वी आर डिस्कसिंग ऑल द पार्ट्स and all the pros and cons of this VHDL programming language, and then we can able to write the VHDL code. हे सगळं समजलं तर तुम्ही त्याचे सिंटॅक्स तुम्हाला कळले तरच तुम्ही VHDL कोड लिहू शकणार आहे, अदरवाइज कसं लिहाल तुम्ही? समजलंय? ऑल ऑफ यू क्लिअर विथ दिस ऑर नॉट? सगळ्यांना समजलं आहे का?
Yes, sir.
Okay, fine. Now again we have one more lecture in afternoon. किती वाजता आहे?
2 वाजता.
Yes, I guess 2 p.m. to 3 p.m. Okay. We will start with this data object part in that lecture. Okay. For now, we will stop here. Okay. We will discuss this part in afternoon's lecture. Okay. Fine. आतापर्यंत आता जे काही मी शिकवलं त्याच्यात कुणाला काही डाऊट असेल तर विचारा. No one? Okay, then I assume that you are through with all these concepts. Okay, that is good actually. Okay, fine. For now, we will stop. We will continue with this data object type in afternoon's lecture. Okay. Okay, one message from your classmate is, sir, please tell me in Marathi some of the concepts due to which we can understand the concept. All of you agree with the same. काही पार्ट मराठीतनं सांगायचा का मी कसं मी सांगतो ते but you want me to again repeat the same part in very fluent Marathi? I can, no problem. Yes sir, yes sir, yes sir. Good. Okay, fine. ठीक है. Henceforth I will take care. ठीक है. I will explain that concept in English as well as in Marathi so that you will have better understanding. No problem. Okay. Roll number 1 to 10. Put your roll numbers in chat box. Roll number 1 to 10. 598472 6 10 1. Roll number 11 to 20. 20 17 11 12 15 18 14 13 16. Okay, this much only. 21 to 30. 21 27 23 24 29. 21 to 30. 28. 28 is there. 31 to 40. 38 39 31 34 32 33 37 35 36. 41 to 50. 44 48 45 47 42 49 43 41. Okay, 22 I have marked. Roll number 51 to 60. 53, 57, 56, 54, 58, 51, 53, 57, 56, 54, 58, 51. Okay. 61 to 70. 64, 67, 68, 65, 70, 66, 61, 71 to 74, 74, 73, 72, 71 is there. 46 ओमकार लाड. तुमच्या वेळेला द्या की हो तुम्ही प्रेझेंटी. Okay, fine. I have marked. All of you can leave now.